All right, so here we got the notes for positive, negative, increasing, decreasing, and the average rate of change. So important information here. Relation is positive if its y values are positive, meaning above the x-axis, and negative if its y values are below the x-axis. So on the x-axis is not positive or negative. 0 does not have a sign. The relation is a value of 0 where it crosses, right down here, meaning it's not positive or negative. It's increased and it has a positive slope. The graph is climbing, so it's increasing as you read from left to right, and decreasing if it has a negative slope, so falling when you're reading from left to right. Average rate of change is the slope of the line, so you have the function notation version, or probably the version you're more familiar with, the y2 minus y1 equals x2 minus x1. Okay, so positive and negative domains. Determine the domain in which the following graph is positive and negative. So the first thing we want to look for is where the graph cross the x-axis, because that's where it's going to switch. So the graph is positive wherever it's above the axis. So here, and anywhere left of that open circle. So left is a less than sign, so for x is less than -9 is positive. Or you've got this side over here, any place x is more than 1. So negative is going to be this section in the middle, in between. So to write an in-between inequality, the x goes in between. Now note there are no or equal to bars, because at -9, whoops, that should be a -1. At -9 and -1, it's on the x-axis, and 0 is not positive or negative. All right, so next one. So once again, find your zeros first, so there and there. So at -5 and -1. So this graph is positive in the middle, so between -5 and -1, it's positive. So negative is this part here, everywhere left of -5, so it points to the left, or everywhere to the right of, points to the right, -1. All right, so our next guy, our zeros are at -6 and -2. So positive, there's 2 places here and here. So everywhere left of -6, or everywhere right of -2. Negative is the chunk in the middle, so -6 less than x less than -2. The x is in between those numbers, so it gets written here. Alrighty, so our zeros are at 0 and at 4. So our graph is positive between those numbers, so the x goes between the numbers. It is negative everywhere left of 0 or right of 4. So notice the inequalities point to the sides, left of 0, right of 4. Okay, so we got increasing and decreasing. So increasing and decreasing just determines if the graph climbing or falling as you read from left to right, just like with positive negatives determined in terms of the x. So increasing and decreasing. So this graph starts at 0 and climbs till it hits here, and then starts to fall. So the increasing starts at 0 and then climbs until I hit an x value of, looks like about 6. Decreasing then starts at 6 and keeps falling until the x value hits 14. So notice when one ends, the other one starts. All right, so this one has arrows, not endpoints. Now be careful, you're not starting at the bottom reading up, you're to read from left to right. So the place where it switches from increasing to decreasing is right there at 4. So increasing, decreasing. So if I start at the 4, you're always reading from left to right. So this side is increasing, it's going up. So everything right of 4, which means decreasing is the other stuff, everywhere left of 4. Even though if you start at 4, it looks like this is climbing. Remember, you're reading from left to right. The graph is decreasing, 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 decreasing until you hit 4. So everything left of 4. All right, let's do a couple more here. So once again, no endpoints, so I need to know where does it switch. So it switches right there at about x equals -2. So reading from left to right, this side is the decreasing side, or sorry, the increasing side. So everywhere left of -2 is increasing. For decreasing, then that would be everywhere right of -2. It has to be one or the other. So this last one is like our first one. We have the 2 endpoints. We also have the place in the middle where it switches, which is at 4. So this graph starts here, is increasing So starting at 0 up until it hits 4, and then decreases starting at 4 until it hits 9. Now be careful, it's not what are the y values where it's increasing, it's just the x's. That is a y value of 0, but it's decreasing until it reaches x equals 9. So this one was increasing, this one was decreasing. Okay, average rate of change from the graph. Determine or find the average rate of change following over the specified interval. So just find the slope. Now these are our x values, so -2 and 3. So we are looking between that point and that point. So those two coordinates are -2 comma 0 there, and 3 comma -2 there. And then I just need to find the slope. So y2 minus y1, x2 minus x1. So that's -2 on top, that's +5 on bottom. There's your average rate of change. You could also count from this point to that point. It's down 1, 2 squares, and right 1, 2, 3, 4, 5 squares. You can also just count. All right, so -3 to 2. So there's -3. There is +2 on the x. So those coordinates are -3 comma 4. Be careful with the, oh, I did that one wrong, because that's at -2, 0. And this is -3 comma -20. So that's -2 over 23 is your slope. So your trick about counting squares only works if your axes are labeled the same size. Like this is ones and that's tens, so I can't just count. Same thing down here on this one. This one is ones left and right and twos up and down, so I actually have to do the formula. So -3 comma 4, and this one is 2 comma -8 down here. So y minus y, -8 minus 4, 2 minus -3. So -12 over 5. And if you count by twos, 2, 4, 6, 8, 10, 12, it's down 12 and over 1, 2, 3, 4, 5. But you just count by ones. Alrighty, last two here. So 4 and 8. So x equals 4 is right here. So 4 comma -30. 8 is right here. 8 comma -10. So y2 minus y1 over x2 minus x1. So -10 minus -30, that's -10 plus 30. So that's 20. And that is 4. So this just comes out to be 20 divided by 4 is 5. All right, last one. 3 is right there. So that's 3 comma 6. And 8 is right there. 8 comma -2. So y minus y, x minus x. So that is -8 over 5, and that does not reduce, so that's my answer. Now do be careful. Remember, it's y is on top, x is on bottom. Now the order I did, if you notice, I always did this one minus that one minus that one. You can do top minus bottom, like I could have done 6 minus -2 for the numerator here for the y's. But if I do that, I have to do 3 minus 8. So if you do this one first on top, and this one second, on the x's, first on bottom, second on bottom. But that brings us to the end of the section.